Welcome to the third video on the beam deflection lab. In this video we'll go through how we should be determining, how we should be drawing up the plots for the theoretical and experimental values of deflection, and then we'll talk about how we should be calculating the Young's modulus for the theoretical values. Have fun! When considering the deflection plots, you're going to find that they should look more or less linear. I know this is aggressively noisy. I did that on purpose. But so what you're going to do, right? You're going to find theoretical deflection as a function of p, but you're also going to take these experimental values and you're going to use them. You're going to find a best fit plot. You're going to force it to go through the origin 0, 0, right? Because the deflection with 0 force had better cause 0 deflection. So you're going to force that, and then you're going to give us the r squared value and all that. So force it to go through, through 0, 0. There we go. That'll be very easy. For the theoretical one, and to get the Young's modulus, what you're going to need to do is you're going to have some equation, right? You're going to say that that y as a function of x is equal to 1 over ei, and there's going to be a whole bunch of junk going on. Right here it's going to be like p times, some constant, not necessarily of integration, but just a constant, times, x squared plus p times c2 times x plus p times c3, and then plus 0 for that. So I'm not going to worry about any of this right now. Okay, let's just worry about this stuff because we're going to solve for e. So what that's going to require is you're going to multiply both sides by e, obviously, and divide both sides by y. So you're going to end up with a value that e is equal to, I'm just going to write parentheses for all that, divided by I times the deflection. And you can go ahead and factor p out. P is present in all of these, right? Now, when you're generically doing this, you are going to have one more constant of integration, but that's going to go away once you have introduced the boundary condition that the deflection is 0 at the beginning, at the pin. So once you do that, there is the ability to factor out p. So I'm just going to put a p on the outside right there, and you can just know that the inside of these parentheses is just a jumble of constants and x to various magnitudes. So that's going to be the slope of our deflection plot, and this right here should tell us the Young's modulus. So find us the error between the theoretical Young's modulus that we get from doing this and the Young's modulus that we get from the equation that we'll get from this.